How does a halocline form? Have you ever wondered how different layers of water can exist side by side without mixing? This fascinating phenomenon is known as a halocline. So, how does a halocline form? A halocline occurs when two layers of water with different salt concentrations meet but do not mix right away. This creates a clear boundary between them. The reason for this separation is simple. Saltwater is denser than freshwater. When freshwater from rivers, rain, or underground springs flows over or meets saltwater from the ocean, the difference in salt content causes the water to form distinct layers. The halocline is the area where salinity changes rapidly with depth, marking the transition from the less salty surface water to the saltier water below. This layering happens because the difference in salinity affects the density of the water. When the two layers meet, they resist mixing, creating a barrier. This barrier plays a significant role in how nutrients and oxygen move through the water. For marine life, this means that there are different habitats above and below the halocline, influencing where various species can thrive and how nutrients cycle through the ecosystem. In coastal areas, estuaries, and underwater caves, haloclines can often be seen as shimmering or blurry layers underwater. A great example of this is in the cenotes of the Yucatan Peninsula. Here, freshwater from underground springs sits above the saltwater, creating a stunning visual effect and a unique environment for marine and aquatic species. The position and strength of a halocline can change based on several factors. Ocean currents, wind, temperature, river runoff, and melting ice all influence how freshwater and saltwater interact. These factors also determine how stable the halocline remains over time. In polar regions, haloclines help protect sea ice by preventing warmer, saltier water from mixing with the cold surface water. This is essential for the survival of marine life that has adapted to cold conditions. Overall, the formation of a halocline shapes underwater ecosystems by creating layers with different physical and chemical properties. This layering affects nutrient availability, species distribution, and the overall health of marine life. Understanding how haloclines form helps us appreciate the complexity of our oceans and the diverse life they support.